All right, so today we're going to talk about isotopes. And you might commonly know of the phrase isotope or the word isotope probably from TV or movies. Somebody might talk about an isotope somewhere. The Simpsons baseball team for their town, Springfield, was the Isotopes. Too old of a reference. Got it. Anywho, we're going to talk about isotopes today. But before we talk about isotopes today, I want you to introduce yourself to your periodic table. Your periodic table looks like this. You're going to probably need it out on your desk multiple times throughout the course of the day today. So you should become familiar with the periodic table. We're going to talk about the different parts of each box. So be prepared to learn about that. Now, the thing of it is that all periodic tables are kind of set up the same, but sometimes they're just in a different order. So for example, here is our element name. And here is our element symbol. Okay. And here, this number right there is known as the atomic number. And then this number down here is known as the average atomic mass. And then lastly, let's see. We've got this situation here, which is not on every periodic table, but it's on the periodic table that we use a lot, and that's called the electronegativity. Okay. And that's going to become really important in the next unit or so. But for now, you just should be familiar with it. Now, there's another. So that's the basics. But you might notice that there's some other elements on the periodic table that are written a little bit differently. Like for example, Au is gold. And what I want you to notice here is that A is capital. I think I spelled that wrong. And U is lowercase. So when you have an element that has a symbol with two letters, the first one is always going to be a capital letter, and the second one is going to always be a lowercase letter. And when you have a symbol that just has one letter, the first one, the only one, is going to be capital. So make sure that you're doing that correctly. Now, any questions about that so far? Because we just got to meet our periodic table. Like I told you, this one, mine, I always name. It's Jethro. You should name yours. I have a former colleague that didn't get a second date once because she admitted that she carried a periodic table around in her wallet. It's true. So, yeah. Anyway, moving on. I know it says isotopes, but I'm going to say pizza because to me, this is what's really important. When you go into the Little Caesars, right, which is delicious, but the only really good thing at Little Caesars is the breadsticks. Convince me I'm wrong. Right? That grease that's on the outside of the breadsticks is just so good. It's so good. But the point that I'm trying to make is when you go into the Little Caesars, you don't walk in and be like, pizza. Like the person behind the counter isn't like, hi, welcome to Little Caesars. What can I get for you today? And you just walk in and yell pizza. That person is going to look at you like, we have 3 kinds of pizza and then other options that you can make. What kind of pizza would you like? And you're just going to be like, pizza. So they're going to grab something off the shelf and then you're going to open it up. And just like every Karen, you're going to complain that you got the wrong pizza, but you didn't communicate properly. But if you're like me, you go in and you get 3 pizzas because cheese is good and pepperoni is good and sausage is good. So you get all of them. And then you do the same thing that I do is you take, yeah.
I work in a pizza place. I take calls, and so many people call and just say, "Can I have pizza first?" Why else would you be calling?
People are.
Although sometimes people do call only for wings, which we're out of most of the time. But
It's like the McDonald's with
that
the.
literally has pizza in the name for wings.
I feel your pain because people, man, I don't understand. Anywho, so the thing of it is that when you order the pizza, you go to the Little Caesars and you get the 3 pizzas, right? You get the cheese, the sausage, and the pepperoni, right? And you bring them home and you do the same thing that I do. You put them on a scale and find out that the cheese weighs a very specific amount, and the pepperoni weighs another amount, and the sausage weighs another amount. And which one do you think weighs the least? Why? Because there's not extra toppings on it. And those of us that know how pizza is made know that when you order a pizza, right, the guy back there or the gal back there who's making the pizza is supposed to follow the protocol of using the cheese scoop, which is a very specific volume of cheese. So all the cheese pizza, the pepperoni pizza, and the sausage pizza also have the same amount of cheese on it in theory. Right? So far, so good. The reason why that's important is because going back to the beginning, when I said if you walk into Little Caesars and you say pizza, they're going to not know what to give you. But an isotope is an atom of an element, okay, that has the same number of protons, same amount of cheese, but different toppings or different amounts of toppings on the inside, like pepperoni or neutrons. So what I'm getting at here is that pizza is a blanket term for all the different flavors or varieties of pizza. Isotopes is a blanket term for all the different varieties of an atom, of an element. So what I'm getting at is that if I take a bucket of aluminum or aluminium, depending on which side of the pond you're on, and I take that bucket of aluminum atoms and I dump those bucket of aluminum atoms on the table and I inspect them, magic school bus style, they're going to all look the same. They're going to behave the same. They're going to sound the same. They're going to taste the same. But some of them are going to be slightly heavier, and we're going to try to understand why today. So, all atoms of the same element have the exact same number of protons in them, which is super important because the number of protons is sort of what makes the atom unique. And we know that to be the atomic number. So if I go back up to my drawing up above, the atomic number is also the same as the number of protons. Okay, number of protons. Now, okay, so in a neutral atom, the number of protons and the number of electrons will be the same. But elements can have different numbers of neutrons. And when that happens, we call those atoms, those pairs of atoms or those types of atoms, we call them isotopes. Now, because protons and neutrons account for the mass of an element, that means that the mass number of an element can be different. So there's a generic formula here which says mass number of an element is equal to the number of protons that an element has plus the number of neutrons that an element has. And that's going to be kind of important in a minute. Why are electrons not part of this situation for the overall mass of the atom? What did we learn about yesterday?
Small.
Electrons are small, and their mass is negligible. So we remember that electrons is negligible. Okay, so just remember that. So on the next page, you should see a table that we're going to fill in. Yes?
Can you go to the slide before just real quick? Okay, never mind.
So this is where you're going to work off of your periodic table, right? So you got your handy dandy periodic table out, and you're going to locate, we're going to work across the first row. The first row has got Fe. Fe happens to be the elemental symbol for iron, right? And if you locate iron on your periodic table, hopefully you will notice that iron has a symbol of Fe, and its atomic number, according to the periodic table, is, anybody locate it yet? It is 26 indeed. Okay. Now, we just said that the atomic number is equal to the number of protons. And we also said that if the number of protons and electrons are equal, we have a neutral atom. And now we need to determine our mass number. And our mass number is determined by taking number of protons plus number of neutrons. So in this instance, we know the number of protons to be 26. We know the number of neutrons to be 32 because it was given to us. So that's going to give us our mass number of 58. Okay? Because as you may recall, mass number, which I'm going to call Mn, is equal to number of protons plus number of neutrons, as you might recall. Now, in the next row, we don't have any letters at all, so I'm guessing it can't be done. Or can it? What do you think? Can we do it? Yeah, we can. For sure. What does the atomic number tell us? It tells us the number of protons, for sure. And in this case, we have 16 for the atomic number, so we have 16 for the number of protons. And then what else can the atomic number tell us specifically about the atom itself? It can tell us the identity, which in this case, if we locate element number 16 on our periodic table, we'll locate that it is sulfur. And if this is a neutral atom, and it is until I tell you otherwise, it'll have 16 electrons. So how are we going to figure out the number of neutrons? Well, we're going to take the mass number minus the number of protons to give us our mass number, or to give us our number of neutrons. So, in this instance, our mass number is 36, minus the number of protons, which is 16. And 36 minus 16 is, last time I checked, 20 for our neutrons. So I'm going to write this formula up there just for us to keep track of. Okay. So, as pointed out in my last hour, wait, we have sulfur. So clearly somebody made a mistake. So why are we doing sulfur again? And I said, oh, no, it's not a mistake. It's something that we're doing. So sulfur, S, has an atomic number according to the periodic table of 16, which means its number of protons is also 16, which means in a neutral atom, which these are, it's also 16. But the mass number is the sum of the protons and the neutrons, so it's protons plus neutrons gives us the mass number. So in this instance, the protons are 16. The neutrons are 21 because that's given to us. So that means that our mass number is going to be 37. So what happened is that means that these two atoms of sulfur are isotopes of one another. So now we're going to go ahead and give it the old GHS try. You're going to try the next two rows. Ready, set, do the next two rows. Hopefully you came up with cobalt having 27 for its atomic number and 27 protons, 27 electrons, and 59 for its atomic number. Hopefully you identified the other element in the last row to be fluorine, which had an atomic number of 9 and a number of neutrons of 10 and the number of electrons of 9. So hopefully you came up with those values. Questions so far? Okay. Moving on. So if we go into the Little Caesars and we just say pizza, and then we get the pizza home and it's the wrong pizza because we didn't communicate well, that's more of a bad on you than it is a bad on the Little Caesars, right? Like for real, you got to be able to communicate very well. So in this instance, I'm going to show you how we communicate the different types of isotopes of the atoms that we're working with. In the case of the nuclear notation over on the left-hand side, you can see that we have the element symbol. We have the atomic number on the bottom, and we have the mass number on the top. And so that's a nice little package for how we keep track of what goes where. In the hyphen notation, we have the element name written out, and we have the mass number. And so we're going to have a little bit of practice with that with each of these options. So, with nuclear notation, the mass number is on top, and the mass number is the sum or the total of the protons and the neutrons. And the atomic number is on the bottom, which is just the protons. Now, as practice for that, we have something that looks like this. So carbon, all carbon atoms have, and if you locate carbon on the periodic table, it's element number 6, which means it has 6 protons. So its atomic number is 6, so it has 6 protons and 6 protons and 6 protons. When I go to write its nuclear notation, what I'm going to do is I'm going to go ahead and firstly, I'm going to write the symbol for carbon, which is C, 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 all capital. I'm then going to go ahead and say, well, on the bottom, I have to have the atomic number, which is the number of protons. So I'm going to put 6 on the bottom here, 6 on the bottom here, and 6 on the bottom here. Now on the top, I'm going to take the mass number, which is the sum, or I'm going to add up the protons and neutrons. So 6 plus 6 is 12, so that's going to go on top. 6 plus 7 is 13, so that's going to go on top. 6 plus 8 is 14, that's going to go on top. So that's how we do that. So practice the next one. So hopefully you found chromium to be element number 24. Hopefully you found that meant, or that told you that the element had 24 protons, 24 protons, and 24 protons. You were given the number of neutrons, so the number of protons plus the number of neutrons is equal to its mass number. So 24 plus 20 is 44, which goes on top. 24 plus 22 is 46, which goes on top. And 24 plus 24 is 48, which goes on top. And hopefully yours look like that. Questions? All right then. Hyphen notation. Remember, it's the element name followed by the mass number. And if we forgot, for my example, carbon 14 would be carbon atom with 6 protons and 8 neutrons. Because again, the mass number is the sum of the protons and the neutrons. Because we've said it like 35 times today, why don't we say it one more time? Protons plus neutrons for our mass number. And while you're wrapping that up, you might want to go ahead and locate uranium on the periodic table. It's a big one. It's somewhere between element 94 and element 90. So if you've located it, or if you need more direction, it might be before 93, or it might be between 91 and 93. Yeah. Which has 92 protons. And now, just like we did before, well, not just like we did before, but now we're going to go ahead and write the hyphen notation. So here I have uranium, and I'm going to write out its name. And then after the name comes the mass number, which is we add up the protons and the neutrons. So 92 plus 142 is 4, 3, 234. So it's uranium 234. In the case of protons, 92, or in the case of the second one, I've got 92 plus 146. So that's going to be, let's see, an 8, a 3, carry the 1, 238. So it's going to be uranium 238, which is my favorite uranium. All right. Now, you try neon, which is a much, 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 much smaller element. Go ahead and locate neon for you. And hopefully you located neon to have 10 protons because it has an atomic number of 10. So 10 protons, so plus 10 neutrons is 20, so it's neon dash 20. 10 protons plus 12 neutrons is 22, so it's neon dash 22. Now, a common mistake that students make is that they will want to write, for example, Ne dash 20 or U dash 238. And when we're doing hyphen notation, you actually really do need to write the name and not just the symbols. Okay? All right. The last slide is a little bit of practice for you. So go ahead and give that the old practice. Can I help you? Why? Who? Okay, so you go ahead and practice these guys right here, and then we'll go over the answers in a second. So what I have here is I have the, in the case of the hyphen notation, I simply wrote out the element name sodium or krypton dash. And because I was given the mass number in the information that was presented to me, I just simply copied it over. So the 24 came after sodium, so sodium 24. The 73 came after krypton, so krypton dash 73. In the case of the nuclear notation, though, what I did not have was the number of protons of the atomic number. So I had to go to the periodic table and locate that. So I located for oxygen, the atomic number was 8, which gave me 8 protons. So I put that on the bottom, and then the mass number I simply put on top, followed by the symbol. For copper, I located that the number of protons or the atomic number was 29, so I put that on the bottom. I then put 70 on top because that's the mass number, and followed by the symbol, which is copper. Questions? All right, so that is the information you need to know to be able to do the homework tonight.